Good morning. Welcome to Physics World. Today we discuss about chapter 5, sound. Every day in our life we hear so many sounds like dog barking, ringing of a bell, the sound produced when you pull the door or push the door, screaming, shouting, talking, the sound produced when the vehicle apply the brakes. In all these examples, one thing is common, that is sound. But the surprising thing is that all these sounds differ. Even though they differ, we are identifying those sounds with their differences. How it is possible? To know more about these things, let us explore sound and its properties. Now, the first question comes in our mind is, how to produce sound? Yes, here is something written on the board. Vibrating body produces sound. Then what is meant by vibrating a body? So let me explain you in detail. Take a metal stick or metal rod. Say it's an iron rod. Take a hammer. It's a hammer. Now, hit the metal rod with the hammer. Then what happens? You hear a sound. And while the sound is produced by the iron rod, touch it. What happened? You feel something vibrating. Similarly, you blow a whistle. When you're blowing the whistle using the small device, if you observe carefully, inside the whistle, the ball moves. Why the ball is moving? You're playing the flute. You see that so many persons playing the flute. They'll move the fingers on the different holes on the flute. If you move the fingers on the holes of the flute, you will experience something is moving inside. What is it moving inside? When you take a guitar and plug the string of the guitar, then you see what happened to the string. It moves. So all these movements are nothing but vibrations. Sound cannot be produced without the movement of the part of a body. That movement in physics we specifically called as vibration. So with vibrations only sound is produced. When I am speaking in front of you, I am also producing vibration to my vocal cords. My vocal cords inside are vibrating. That's the sound is produced by me. So all this example clarify you that sound is produced because of a vibrating body. Now see this diagram. There is a table. On the table, a hexa blade is placed and it should not fall on the ground. So it is supported with a heavy weight support so that this end is fixed. And the other end is not supported. Other end is just in the air. Now just you with your finger, you apply little force on the hexa blade. Then what happens? The blade starts moving up and down. That you can see physically with your eyes. So the movement of hexa blade up and down is what called vibration. So some objects, vibrations you can easily see with your physical eyes. Some objects vibration you can't see. For example, ringing of a bell. In your school, the metal bell will be there. With the hammer, one person will come and hit on the bell. You can hear the sound, but you can't see the vibration because those vibrations are very small and very fast. You can only experience when you touch the bell. In that way, this example also proves that using the body's vibrations only sound is produced. Now see, sound is not at all sound. Sound is energy. I can say sound has energy, but sound is energy also. How could we prove that sound is energy? See this example once again. You can do it at your home also. Very easy and safe experiment. Take a glass. Inside the glass, what will be there? Nothing? You can't say nothing. You have air inside. Yes. So air is inside. Now, take the balloon and expand the mouth of the balloon, stretch the mouth of the balloon, or put it on the mouth of the glass. Then put your ears near to the balloon surface. This balloon surface is called membrane. Membrane. Which membrane means a surface which is having elastic property. Right. Now, do you hear any sound? No. Now, remove the balloon membrane. Now, keep a cell phone inside, as I am showing the diagram. Keep the cell phone's ringtone played with high volume. Now, again keep the balloon membrane on the open or mouth of the glass. Now, what happens? Observe carefully. Then the membrane of the balloon starts moving. Still, you are unable to understand that whether the membrane is moving or not. Add some sugar crystals or salt crystals or small sparkling materials on the membrane like this. Then what happens? Whenever the sound is played by the cell phone inside the glass, these sound waves goes and hit the membrane. They hit the membrane. When they hit the membrane starts vibrating. When the membrane starts vibrating, these crystals also move up and down. That physically tells you that yes, the body is vibrating because of sound. And that membrane is vibrating because sound has energy. Because with the energy only you can apply the force. Sound has the energy, that's why it's applied to force in the membrane. That's why membrane is vibrating. So this example clear you that sound has energy. And because of the energy, sound produces vibration to the body. Take another example, simple example will tell you. Suppose somebody screams in a closed room in front of you. Now what you will do? Immediately you close your ears. Why? Because you are unable to hear that sound, because that is painful to your ears. The painful is the force to ears. And that force, because sound has energy. In movies also they will show you. Just for fun they will show you. But actually it is correct. If woman shouts with high pitch, the glasses break sometimes. Or in the kitchen, the steel utensils starts producing sound. Because sound has that much of energy. Because of the energy only all these things are happening. So we understand that each and every object has the ability to produce sound. And to have better sound, or I can say to have pleasant sound to your ears, so that you feel very happy, you get the happy moment. Yes, we have some more instruments called musical instrument. I don't think on the planet Earth nobody likes music. Everyone fan of music. So this music played by musical instruments. We have different musical instruments. Some instrument I have written here. Tabla, drums. These are called membrane instruments. Why is it called membrane instruments? If you see the tabla and drum, both the ends of the tabla or the drum, their elastical membranes are attached to it. So if this is the drum, these ends are called membranes. Membranes means elastically stretched and very thin. So these are called membrane musical instruments. So what happens when you hit on the membrane? Inside you have hollow space. Inside there is no mass. Hollow space. So when you hit on the both sides of the membranes, the sound is produced, and the sound produced and goes to the other side, reflects back, again come to this side, again reflects back, so that multiple reflections of sound produce huge amount of loudness. And with the perfect tune, you can enjoy that music and sound also. So coming to this one, guitar, violin, veena. In all three categories, one thing is common. What is that? String. These are called string instruments. String. Today everyone fan of the string instruments only. The rap music, rock music are played using string instruments. So if you take the guitar, you have to plug the string. Veena, you have to plug the string. The string starts vibrating, produce sound. Jal Tarang. Have you heard about Jal Tarang? You can do it at home also. How? Let me explain you. take some 5 to 6 empty glasses. 1, 2, 3, 4, 5. So 5 empty glasses I have taken. Now fill the glasses with water, but with different levels. Like, see here you fill the water till here. The first glass, the water level is till here. Second glass, the water level will be little increased. Third glass, the water level will some more increase. Like that, increase the water levels, so that you are actually keeping the air column gap. This is called air column, because in this area you have air. This is water. This is called air columns. So actually what you are doing, you are varying the length of the air columns. Now what will you do? You take a stick and first hit on the, don't hit very hard, it breaks. So take the stick and hit smoothly on the first glass. You can hear some sound. Now keep on hitting all the glasses continuously. Then you can hear a very good tuned sound. This is what called Jal Tarang. So here the principle behind is that, yes, you are producing the sound because of vibrations only. And here you are vibrating the air columns, the varying air columns. This is the same principle for flute also. To the flute, you have holes. When you want to play the flute, actually what you are doing, you are blowing the air inside the tube. And this air heights you are changing by closing, opening the holes on the flute. So by placing a different systematic, keeping the fingers on the holes, you are changing the levels of the air or heights of the air, and then music is produced. So in all these cases, even though the musical instruments are different based on their categories, all they are producing sound because of vibrations. So sound we also produce. All animals, human beings produces sound. When we speak, when we talk, we have to produce sound. And I can say that because of sound only we have some type of communication with ourselves. This is what we called a non-verbal communication. Okay, now see the diagram here. Generally in the human beings, the sound is produced because of this part, the neck part. Inside the neck part, you see the main part which is producing sound is called voice box. And this voice box technical name is larynx. So in this voice box, you have two muscular ligaments. This is one, this is two. And these muscular ligaments are also called vocal cords. And these vocal cords placed at the end of the windpipe. So these muscular ligaments are the main part. They will actually vibrating. Because of that, sound is produced. How? See this diagram. Here, the two muscular ligaments opened here, closed here. When you breathe the air, then these two muscular segments open up. The air goes inside to the lungs, and the two ligaments are closed. Then when you want to start speaking, the air is actually inside and pressed between the slits and make those slits means I want to say ligaments, make the ligaments to vibrate. In that way you can producing the sound, and that sound is coming out from your mouth. These vocal cords differ in the length between men and women. Men have the length of 20 millimeters, women have 5 millimeters. And if you go to children, they have very shorter than women's vocal cord size. You understand that how to produce sound, and sound is the another form of energy only. Now, when you produce sound, how sound can move from source to a destination point. Suppose I am speaking in this room, so I am the source of sound which I am producing. This sound has to go to the different devices or the persons who are in this room. So how it travels? It travels because of medium. So sound needs medium to propagate. Without medium, sound does not travel. And what type of mediums we have? Yes, we have three mediums. One is air medium, liquid, air is nothing but gas medium. Third one is solid. So in all these three mediums, sound propagates. But as the mediums are different, in some mediums sound propagates faster, some mediums sound propagates slow. Let us discuss those things after 2 minutes. Now, how do we know that sound needs medium? So here I am speaking, the sound is propagating in the room because air is existing in this room. Through air, the sound is propagating to different points. Now, to test the mediums required, like in our childhood time, we play so many types of things. Like one game is that playing with telephones. What type of telephone we'll play? Actually, not taking the original telephone. We will create a telephone communication using two matchboxes. Like at your childhood also, maybe you have played. So take a matchbox. It's a matchbox 1. Take another matchbox 2, and connect the two matchbox with a string. How much long you want? That much of long. So that if you want to communicate between one room to another room, take that much of long string and tie to both the matchboxes. Close the matchbox. Close it. Now call your friend. Call your friend and tell him to go to the another room. Now start speaking in this matchbox slowly. Now the surprising thing that in the other room, the friend listens what you're saying. He can hear you. Not because of your speaking in the open place. No, as you're speaking into the matchbox, the sound is propagating through the string and go to the other matchbox. In this demonstration, one important thing you have to know: the string should be stiff. Looks like a straight meter stick. If it is not stiff, maybe there is a possibility of no vibrations. So make the string stiff between one room to the other room, between the two matchboxes, then you can enjoy the communication. So I have told earlier that the sound speed differs with the mediums. How it differs? Generally, we will speak generally in the air only. Sound propagates in the air, and speed of the sound in air, Vs, equals to 330 meters per second. Speed of the sound. And this speed of the sound increases when the temperature is increased. Why it is like that? Because when the temperature increases, the particles in the medium starts vibrating. More and more vibrations. Because of more and more vibrations, the speed of the sound increases. So remember, when the temperature increases, there is a more speed of sound. Next, coming to liquids. So what do you think? Speed of the sound is less in liquids comparing to air? Maybe our common sense says like that, but it is wrong. Speed of sound increases in liquids comparing to air. For example, if you take water, the speed of sound is 1490 meters per second. See the number? How fast it is. In 1 second, it travels 1490 meters. That means 1.49, approximately 1.5 kilometers. Speed. That much of fast it is. Now coming to solid, what do you think? Solid, it may be in between air and liquid, or it may be more. Yes, in solid, it is very high amount of speed. Like if you take what you call the solid steel, the speed of the sound is 5,000, approximately I'm writing 5,000 meters per second. This approximate number. Different textbooks give different numbers. But the point what you have to get, that speed of the sound in solids is greater compared to liquids and air. That's why, suppose in your school you have 3 floors. Tell your friend to go to the first floor, but one condition, you have staircase. To the staircase, you should have steel supports. Like when you are climbing the steps, you will have a support. With the support on the side, you will climb the steps. The steel support will be there. Okay, you tell your friend to go to the ground floor, tell him to put his ear which is touching the side support, steel side support. So at the top of the floor, you speak something in the air. He couldn't listen. He couldn't hear anything. Now, you make some sound at the top of the floor with some finger or with some object. Immediately, this person can hear the sound. But the same sound, if you make in the air, that sound may not be reached to his ears, because speed of sound in solids is very faster, and so that sound he can hear quickly when he keep his ears touching to the side support, which is made of steel. So in that way, the speed of sound decreases from solid to air or solid to gas. Now we understand that sound can travel in gas medium, liquid medium, as well as a solid medium. Now the very important thing is that sound cannot travel in vacuum. When there is no medium, sound cannot be traveled there. How do we know? How can we test it? See this example once again, the glass with cell phone. So you play the ringtone in the cell phone with high volume. Okay, the glass, the top open surface is opened, the mouth is opened, so you can hear the sound. Now it is little bit difficult, but try. Keep the mouth of the glass inside your mouth and suck the air. Try to suck the air in the glass. Then tell your friend to observe the sound produced by the cell phone. Then observe that while you're sucking the air from the glass with your mouth, the sound intensity gradually decreases. If you are successful to hold the air from the glass, then the person who is observing the sound, he will say that he can't hear any sound. So that demonstration tells you that yes, to produce sound or to hear any sound, medium is required. Generally, that vacuum is created using a pipe called vacuum pipes. So in the high level physics laboratories, the air can be sucked using these vacuum pipes, so that they can produce a region without any medium. Even the sound is produced, you can't hear it. In human beings or animals, the main part to hear the sound is ear. If the ear is not there, you can't hear anything. So inside there is a critical mechanism happens to understand that some sound is produced. Immediately once somebody produces sound, immediately hear the sound and recognize. But in between the producing the sound and the recognizing, in between there is a lot of mechanism happen inside the ear. So what is that? When we produce a sound, those sound vibrations are caught by the outer ear. Then they travel through ear canal, and they will hit the eardrum. Then the eardrum starts vibrating, and those vibrations are carried by the bones, malleus, incus and stapes. And now these vibrations goes to cochlea, and inside the cochlea you have some fluid, and those fluids take those vibrations, and those fluid particles starts vibrating, and those vibrations are sensed by the hair, and that hair connected to nerves. And these nerves converts our sound vibrations into electric pulses, and these electric pulses carried through nerves to brain. Then brain get the message that some sound is produced. When the brain get the message, then you recognize that yes, one particular type of sound is produced. Just imagine how much of big mechanism is involved inside the ear.